So good afternoon, everybody. I've been doing this for quite a long time, looking at water beetles. This is something that I'm reasonable, I think, at doing. Okay, so there are large numbers of water beetles in both senses of the phrase, which occur in water, either in their adult or juvenile stages, and quite often in both adult and juvenile stage. This talk will therefore give a basic introduction to some of those which can be found in Britain and Ireland. All three of the currently recognized suborders within the order Coleoptera are represented in fresh water and can be found in our area, though some of them are so small as to be almost invisible. I'm not going to include really tiny ones in this presentation. One of the first things many people want to know about any group of insects is how many of them are there. For the water beetles, this is a complicated question to answer because they are not a compact and closely related group. Most people think of the big ditiscid water beetles, the big diving beetles and their relatives when they think about water beetles. Many people also recognize whirligig beetles as being water beetles. But very few people think of the family Elmidae, the little riffle beetles, as water beetles, or indeed the reed beetles of the family Chrysomelidae. Most members of the Hydrophilidae look, at first sight, as though they had fallen into the water and should not really be there. If we look at the main aquatic families then, taking them in order by number of species, we have the Ditiscidae, which are aquatic as both adults and larvae. The Hydrophilidae, many aquatic but some terrestrial. The Hydraenidae, which are aquatic as both adults and larvae. The Halophoridae, mostly aquatic, but some of them terrestrial, and the larvae live in the muddy margins rather than in the water itself. Haliplidae are aquatic both as adults and larvae. Skirtidae are aquatic as larvae, but their adults are not. The Gyrinidae, of course, the whirligig beetles, are aquatic as both adults and larvae. The Elmids, the little riffle beetles, are aquatic as adults and larvae. And the Noterids, which look very like ditiscids, are aquatic as adults and larvae. And then the four families with just one species are all semi-aquatic. They tend to live in wet places, sometimes on the margins of ponds and streams, and sometimes in the wet mud beside them, but they are counted as being aquatic beetles. Having seen what sort of numbers of species there are in the different families, it must be borne in mind that some of those families, many species are terrestrial rather than aquatic, and a large number a large number of the families are mostly terrestrial with just a few aquatic species. And that, of course, includes the Chrysomelidae. There are over 250 species of chrysomelid beetles listed as British. But The reed beetles comprise a little subfamily, the Denacinae, of their own, with just 21 species in 3 genera. And these two pictures are of Denacine beetles, Platymaris and Macroclea. And the Macroclea is quite an interesting species, or rather group, because they spend most of their adult lives underwater, as well as the juvenile stages, which for all Denacines are feeding on plants in the water. Now, let's concentrate our attention on those aquatic beetles which most people will recognize as being water beetles. What is it about them that makes members of the Dytiscidae in particular recognizably water beetles? It's their more or less smoothly rounded and streamlined shape, together with the form of the hind legs, which are the oars with which they swim. All of the specimens in this display box are, in fact, swimming and diving water beetles. The ones on the top row, however, are not members of the family Dytiscidae. If you watch a Dytiscus or other members of the Dytiscidae swimming, you will see that the 2 hind legs work together simultaneously, like breaststroke, a leg action which is highly efficient and powerful. Not all of the Dytiscids have the same sleek, streamlined shape. Some of them are quite short oval when viewed dorsally. Some are very deep-bodied. Some, such as Hydrus ovatus, highlighted here, are almost spherical, which makes some of these species relatively less powerful swimmers than the others, but they all swim with that same simultaneous leg action. The Noterids resemble the smaller Dytiscids so closely, both in shape and swimming behavior, that at first sight they can be mistaken for members of that family. The antennae are not as thread-like this is a female specimen, and the antennae are not as broad as they would be in the male specimen highlighted from the box. The other way of telling whether you've got a Noterid or a Dytiscid is to look at the underside. The Dytiscid has a very different shape to the coxal, the hind coxal processes, which are quite a flat platform in Noturus, rather than in the big Dytiscidae. The Haliplidae and the Hygrobiidae are much less streamlined in shape and do not swim quite so efficiently. Not only are they less streamlined when viewed dorsally, they're also deep-bodied and barrel-shaped, indeed almost globular. I should mention at this point that this display box was made up many years ago, and the family name Hygrobiidae is no longer used. Hygrobia hermani, the squeak beetle, have since been placed in the family Pelobiidae. If you watch Haliplus swimming, you will see that the hind legs are used alternately, and the beetle's progress through the water is somewhat zigzag. All the adults beetles in these families come to the water surface to renew their air supply. They carry an air bubble in the space between the dorsal surface of the abdomen and the elytra or wing cases. This makes them buoyant, and they are able to rise to the surface passively. They break the surface film with the tip of the abdomen so that the contents of the air chamber can be renewed. They may stay at the surface for some time, but it takes no effort and energy to do so. Or they may dive and swim below the surface. In order to conserve energy, they spend a lot of time clinging to the substrate or to vegetation below the water surface. The whirligig beetles of the family Gyrinidae are highly distinctive. Shape is absolutely characteristic, and they can swim on the water surface film, as well as dive and swim below the water surface. They also carry an air supply in the space between the dorsal surface of the abdomen and the elytra, which they renew by coming to the surface. Both of their hind legs and middle legs are used for swimming. The middle legs and hind legs both being modified as paddles. And it has been shown that they normally swim using the middle pair of legs and only bring the hind legs into play when they need full acceleration. Because they spend so much of their time on the water surface, their eyes have split horizontally, so they have effectively two pairs of eyes. One pair on the dorsal surface of the head for seeing above the water surface, and one under the head for seeing in the water. I mentioned earlier on that some of the water beetles in the family Hydrophilidae look more as though they had accidentally fallen into the water than actually belonging there. This is not true of the biggest species, Hydrophilus piscius, which can swim quite effectively and is our biggest water beetle. I have never seen Hydrophilus piscius myself. It's not a widespread and common species, and therefore cannot show you a photograph. But this illustration, modified from a book, gives a good comparison with the size of Dytiscus marginalis. Dytiscus marginalis can be up to 32 millimeters long, but at 48 millimeters, Hydrophilus piscius is half as big again. It's an enormous thing. I don't intend to take you into the world of water beetle identification using keys in this introductory talk. For those of you who wish to identify water beetle specimens, these are the books we would recommend. The cover illustration on the second volume of the Royal Entomological Society Handbook shows the difference between the Dytiscid and the hydrophilid method of carrying the air bubble. You'll remember that I said earlier that Dytiscids carry their air supply under the elytra, and here you can quite clearly see that hydrophilids carry it on the whole of the underside of the abdomen, as well as in the elytral space. Like Dytiscids, Hydrophilids need to renew their air supply at the water surface. They do so by coming up head first rather than tail first, and they break the surface film using the water repellent club tips of their antennae for access to the air. Many hydrophilids hold the maxillary palps forward and use them to perform the sensory function of the antennae, which are considerably reduced to perform their hydrofuge function, so that the palps are frequently much longer than the antennae, as can be seen here. Several families whose members have the palpi longer than the antennae used to be grouped together under the name Palpicornea, but this group name is no longer used. Another hydrophilic beetle, Symbiodita marginella, showing the relative lengths of the antennae and the maxillary palps once more. This is quite a small beetle. The card mount is 5 millimeters wide, which gives you a reasonable idea of the size of the actual animal. The Halophoridae, which we've been, the Hydrophilidae, which we've just been looking at, are not the only family to have maxillary palps lengthened to perform the function of the antennae of other beetles. The genus Halophorus has been removed from the Hydrophilidae and given the status of a separate family, Halophoridae, and their distinctive appearance makes them immediately recognizable. The furrows on the pronotum and the Y-shaped furrow on the head mark them out immediately. Adult Halophorus feed on decaying vegetation in the water, though their larvae are predators and tend to live right on the muddy margins, and they feed on any small insects or little worms in the water by grabbing them and dragging them out of the water. The Hydraenidae are another family with very long palpi. They are mainly tiny little beetles, which are algal grazers on the stony substrates of streams and rivers. Hydraena gracilis has extremely long palps in relation to the length of the antennae, as you can see here. A completely different family now, the Elmidae. Another group of tiny little beetles, which can be found both as adults and larvae, grazing on the algae on the stony substrates of streams and rivers. Their legs are very long in relation to their body size, and they have extremely long tarsal claws to enable them to keep a grip of the substrate in swiftly flowing water. The larvae have gills, which they can extrude from a cavity in the tip of the abdomen for gaseous exchange with the water. The adults exchange gases with the water by means of a plastron. The underside of the body is densely hairy, so densely hairy that it is unwettable. This dense hair holds a layer of air which is not compressible by the water pressure and which exchanges oxygen and carbon dioxide continuously with the water, meaning that the beetles never need to come to the surface and can live permanently submerged. Now, Having talked about what the various kinds of water beetles look like, let us take a look and think about where we might find them. What sort of places would you find water beetles in? Well, the answer is almost anywhere, wherever there is water. There is also the possibility of getting them to come to you. Not many of you will have used a malaise trap, but water beetles, which are flying about, do occasionally turn up in this flight interception trap. And talking about water beetles flying about, don't forget to look at fence posts when you're walking from one place to another. This Hellophorus has either just landed on or is preparing to take off from the top of a fence post. Hellophorids are often encrusted with mud. On this specimen, it helps to highlight the grooving on the pronotum, which is characteristic of the family. Many of you will have used a light trap to catch night-flying insects. It is surprising how many water beetles turn up in these traps, and not just little ones. Here we have a permanent trap set up on a nature reserve as part of the national moth monitoring effort. Dytiscus frequently turns up in light traps, and here we see a female Dytiscus marginalis in an egg carton from such a trap. Most people's idea of looking for water beetles is to go out with a pond net to some convenient, possibly favourite place and have a good look. Emptying the net into a white tray and picking over the catch. Identifying and noting what can easily be recognised in the field and putting others into bottles to examine later. Does this look like a suitable place to look for water beetles? 5 minutes walk away, in the midground of this photograph, is a large lake which looks interesting. But let us stop here just for a moment. Not very promising? It's raining a bit. You can see where the drops are hitting the water surface. Let's have a look anyway. No need to get the net out. And yes, there are things here. Hellophorus, quite a number of them. It was worth a look. Now, let's think about some water beetles which can be easily recognized in the field. The squeak beetle, Hygrobia hermani, is instantly recognizable in the field, both as an adult and as a larva. They are predatory in both stages, feeding on small larvae, particularly chironomid flies and small worms, burrowing in the substrate in ponds. And as its name implies, Hygrobia will often advertise its presence in the net even before you have seen it, because it makes a grating squeaking noise by rubbing the front of the pronotum against the back of its head where there are little grooves. So it makes a noise rather like a rusty hinge. And the first time that I came across Hygrobia hermani, I had about 5 specimens in the net, and I knew they were there as soon as I lifted the net out of the water. Didn't need to look in the net at all. Dytiscus marginalis is recognizable in the field by the margins of the pronotum being yellow all the way round, and the underside having bluntly pointed hindcoxal processes. This specimen is a female, as can be seen by the longitudinal grooves on the elytra and by the fact that the front tarsi are not particularly broadened. They look very like the middle tarsi. This is Dytiscus semisulcatus, a different species in the same genus, recognizable in the field by the margins of the pronotum being yellow only at the sides, and the underside of the body being black. Most other members of the Dytiscus genus are orange or yellow underneath, but this one is black. This specimen is a male, as can be seen by the smooth elytra and the enlarged front tarsi, very different from the previous specimen. Acilius canaliculatus. Sorry, I said the wrong name by accident. Acilius sulcatus. There are only two species which look like this, with a very rounded outline and this colour pattern on the pronotum. This specimen is a female, as can be seen from the hairy grooves on the elytra and the narrow front tarsi. Acilius canaliculatus, the other species in the genus. It is easy to tell which of these two species simply by turning them over to look at the underside. Do not be alarmed, by the way, to find that water beetles, and indeed many other aquatic arthropods, are often covered in vorticellid protozoans, which is what this white flocculent material all over this animal is actually. Vorticellid protozoans. And a lot of aquatic animals, or at least aquatic arthropods, seem to carry large numbers of these. But if we turn the animal over, look from the underside, the femora of the hind legs of the Acilius canaliculatus are entirely yellow. If they were black at the base, as in this specimen of Acilius sulcatus, then that is the difference between the two species. So you look at the underside, and if the legs are black at the base, it's the common species, Acilius sulcatus. If they're yellow all the way from the coccyx to the tips, then it's the much less common species, Acilius canaliculatus. This is a male specimen, as you can see from the enlarged front tarsi. Some of the smaller water beetles are also instantly recognizable. This one is Hygrotus inequalis, quite a small globular beetle with the distinctive pattern of yellow markings on a black background. Those are the ones I've prepared to mention to you as being instantly recognizable in the field. There are a lot more that can be instantly recognized in the field, but I could go on for hours, and I don't want to do that. Having identified those specimens which you can recognize in the field, you will want to put your records in. We recommend iRecord, for which you can take a picture or several pictures, up to 4 are permitted by the system, and then release the specimen. So you can actually upload, if you have a mobile phone, you can actually upload records in the field. And you can certainly take photographs in the field so that you could enter your records into iRecord later. As I said before, you search through your catch and bottle up those specimens which need to be retained for later examination. And for doing that, as I said before, these are the keys which we recommend. There are lots of other books from which you can get information on water beetles. And these are just a small selection as examples. There are lots more than just these. Having brought your specimens back, you will need to examine them, either with a hand lens or with a microscope. You can examine them dry or under liquid, under the microscope. But it's easier, in my opinion, to examine them in a liquid, at least for the smaller species. Some of the big ones don't even fit under the microscope in a small dish of liquid. So you do need, for the big ones, to examine them either with a hand lens or the low power of the microscope in the dry state. But if you submerge them and get the lighting right, and the problem there is you must play around with the lighting on your microscope in order to see what best suits your microscope and the way your lights work. A lot of people say you should dry the beetles first, but I find that if you get the lighting right, it's much easier to see a lot of things in a liquid medium. This is a dry beetle, and you can see it's showing a yellow stripe along the margin of the elytra. This is quite a big species. It's about 9 millimeters long. So it's quite easy to see either under the microscope as it is here, or with a hand lens. The next few slides are going to show some of the things that the keys will ask you to look at. These are what are known as castellated teeth on the underside of the abdomen of a Hellophorus. And the key in question will ask you to look at how many of those teeth there are and how big they are. You often need to look at antennae and palps. These are the antennae, and these are the palps. Where you remember we talked about hydrophilids and some of their relatives having enormously long palpi in relation to the length of the antennae. These are enormous. Sometimes you'll be asked to look at the prosternal process. That is this on the underside of the beetle between the front coccyx, the very basal segments of the front legs. So you'll be asked to look at this. striae and punctures on the elytra. One of the things that you need to look at when you start looking at Hellophorus is how many striae there are across the base of the elytra. And you will see here that there's an extra little one that doesn't run right the way to the end. This is called the intercalary stria, or sometimes the scutellary stria, because it comes next to the scutellum. Oh, heck, what's happened? I didn't realize I was drawing on these slides. I thought I was just moving the cursor around to highlight things, to point things out. I'll try to stop doing that. No, I won't. Maxillary palpi. Again, we're looking at a Hellophorus. The key will ask you to look at the shape of the terminal segment of the maxillary palp and to decide whether it is symmetrical about its long axis or asymmetrical about its long axis. Doesn't look very asymmetrical, but in fact this one is asymmetrical. That margin is not a mirror image of this margin. There are all sorts of other things that you will need to look at. Pronotal markings, colour markings on the pronotum, ridges and pits, particularly sometimes on the epipleures of the elytra. That's the reflexed underside of the elytra. And these are the hindcoxal processes, which you will also need to look at from time to time. The shapes of the hind tarsal segments. This is a nice filiform tarsus, and the swimming action uses these long hairs, which you can just about see form a fringe along the tarsal segments, so that the tarsal segments are effectively broadened on the power stroke of swimming by these hairs. In this specimen, the actual segments themselves are quite flattened and broadened, and this one in particular has the individual segments not only broadened but lobed, so that they actually overlap each other. Here we again have punctured striae. Punctures are these tiny little pits, almost like pinpricks, which may simply occur in lines, or which may actually form grooves between ridges. And it is the groove or the line of punctures which is called a stria. We also get quite complex sculpturing at microscopic level of the elytra. And sometimes you'll be asked to see whether these little cellules in the sculpturing are longitudinal, i.e. running with the length of the animal, or are transverse, running across the line, the body line of the animal. you can see that those are running across, even though it's a tiny little segment, a tiny little fraction of the elytron, because you can see the line of punctures there, which are always arranged longitudinally on the elytra. This one is mottled. So we're looking at a mottled pattern of light and dark. And this is a Cilius again, a female with deep hairy grooves on the elytra. For some of the agabus, you'll need to look at a slightly different part of the underside of the animal. Here are the hindcoxal processes, and these are the metasternal wings, immediately behind the insertion of the mid legs. And some of them have quite wide metacoxal wings, and some have very narrow. So this is what you're looking at if it asks you to look at those metasternal wings. On this specimen, arrowed, there's an elytral epipleural ridge which separates this part of the epipleur from this. The epipleur being the very edge of the elytron, which is folded under, so that you can see that from the underside. That is the flank of the elytra there, running up onto the dorsal surface. And there's quite a strong corner ridge running down there, which separates the epipleur from the rest of the elytron. And then here, there's a strong ridge which separates this part under the shoulder from the rest of the epipleur. This one, the epipleur is simply rounded into the corner. There's no ridge there, as there is on this one. If you know exactly how to look for it, that is where it is. Size matters. The big diving beetles are quite large and don't need to be measured by micrometers under the microscope. You can simply use an ordinary ruler to determine how long a dictys is. With a hydroporus, you may need a ruler which is marked in 0.5 millimeter units in order to measure it accurately. But making accurate specimen measurements of tiny animals is a little bit more complicated. For medium small specimens, it's possible to estimate to the nearest 0.5 millimeter if an engineer's ruler is not available to you. Or you could use the calibration slide that comes with the micrometer eyepiece that you can put in the microscope. If you lay a small beetle on the slide, which you use for calibrating the microscope, that is actually a 1 centimeter line with cross lines dividing it into millimeters and tenths of a millimeter. So though here you can estimate that that beetle may be about 3.5 millimeters. If you use this, you could measure it really accurately. Or you might put a specimen in a dish under the microscope and use a micrometer eyepiece to look down the microscope and count how many units the animal actually occupied. You then place the calibration slide on the microscope in place of the animal, and you can then work out a proportion sum to calculate the actual length of the animal in fractions of a millimeter. Subtle differences in shape can be hard to appreciate. Gyrinus caspius is described as being elongate and canoe-shaped, to distinguish it from other species which are described as rounded and dinghy-shaped. But if you only have, say, a specimen of Gyrinus substriatus, and you come to a point in the key where it says elongate and canoe-shaped, as opposed to rounded and dinghy-shaped, what would you say that was? And quite a lot of people, when they first come across this couplet, have difficulty in making that decision, because Gyrinus caspius is not a common species, so you don't come across it all that often, but you do all the time. And because males are slimmer than females, it can be difficult to determine what sort of shape that actually is. If, on the other hand, you have them both together and you can use one as a comparison for the other, then it's very obvious that that one is much slimmer than that one, even if you turn it upside down and look from the underneath. And this again shows you the all four of the hinder legs are paddle-shaped and used in swimming, and only the front legs are not paddle-shaped, as I mentioned before. Now, you may need, in order to identify things, to look at the genitalia. This is a small beetle whose abdomen is just being gently squeezed in order to extrude the tips of the genitalia. Hellophorus male genitalia, the Aedioegus, looks like this. You can very often squeeze the abdomen and just show the tip to about there. You don't always need to extract the whole of the Aedioegus in order to identify something. This is female genitalia of a Gyrinus. Again, the abdomen has been slightly squeezed and the genitalia have been extruded from the tip of the abdomen. Here we have a specimen of Agabus bipustulatus. The abdomen has been squeezed slightly and just the tip of the Aedioegus is protruding. the Ediagus would actually occupy about that much of the abdomen. It's huge in relation to the size of the animal, but for this particular species, you only need to see the tip, so you don't need to extract it all. For some, you do need to extract the whole of the Ediagus because you need to see the base of it as well as the tip. And here we can see how to take photographs down the microscope. This is Sharon using her mobile phone, her iPhone, to take a picture down the microscope of genitalia extracted from a female gyrannus. Now we've talked about voucher specimens or voucher photographs for confirming records, but we haven't talked about what you might do with keeping specimens of your own as reference specimens for comparison with things which you were trying to identify. So if we go back to the box that of specimens that I originally showed you earlier, this is two ways of preserving whole animals, either by pinning, direct pinning through the elytra and putting a label on the pin underneath, or by card mounting, which is a very popular way of keeping specimens stored. The other way is a wet or spirit collection. We tend to do both. I have specimens kept dry, and I have specimens that have been kept in spirit. The spirit collection is kept in small bottles with snap-on lids, and they are stored in 70% isopropyl alcohol. We use isopropyl alcohol because you can easily buy it. Most of the textbooks recommend that you use either ethyl alcohol or industrial methylated spirits, but you need a special permission and licenses from the Inland Revenue, not the Inland Revenue, but from the excise, if you're going to keep those spirits at home. So we use isopropyl alcohol, which is just as effective, but which, because it's an industrial cleaner, you can actually buy almost over the counter. I think that we're almost done. You want to come in, Sharon?
Here again. Right, is that your last slide?
I think that's
so.
It.
At this point, we were going to have a little video, but that's going to be shared with everybody later, I think. So I think we're probably, and I'm not sure how long we've been now, but hopefully it's been okay for you. We've covered quite a bit, I think. And we're happy to take anybody's questions.
Thank you very much, Peter. That was a really nice overview. Covered a lot of ground there, as well as with the beetles, with you know, with keeping specimens and recording as well. We have a first question, I think, from Mike Ashworth. Are adults found throughout the year or mainly for a few weeks/months in the summer?
Adult beetles, simply as adult beetles, yes, you can find at any time. Because if you go out looking for water beetles, there is almost bound to be something there. But various different species have their own seasons. It's very frequently says in the Keys, adults found in all months of the year, but peaking in, say, June and July, or peaking in March or April. So yes, the individual species do tend to have their seasons of abundance, but most of them can actually be found if you go out looking.
Geography is obviously a big factor.
Geography is a big factor in that, of course, because the further north you go, the shorter the season, the further south, maybe the longer the season.
And critically, how you sample. So my advice would be, if you just want to get into beetles, get out and just do it anytime. Anytime, just go out anywhere and just see what you find, and use a range of sampling methods if you can, because you never know what might turn up, especially in light traps.
I suppose one of the real benefits of water beetles is that you can go out rain or shine, and they're still going to be in the pond or other water body, aren't they? So
Exactly.
Yes, yes, they are. It's
not all fair weather entomology, isn't.
But most entomology is more difficult in the rain. Even water beetling is slightly more difficult in the rain because it's not comfortable for you. But it doesn't affect whether or not you can catch them.
Okay, thank you. Was there any follow-up on that, Mike? You could unmute yourself if you'd like to put another question there as a follow-up.
No, that's fine. Thanks, Gary. Thanks, Peter.
Okay. So the next question then is from Dave Boulding, and it's asking, how do we dispatch specimens?
Right.
Good it is.
Right. Now the way we do things is if we need to kill them in the field, we drop them into our 70% alcohol. If you bring them home alive, or take them back to the laboratory alive, then a good way to kill them is a little bit of boiling water. What I used to do at home in my mother's kitchen was to put a small saucepan on the stove, get the water boiling, borrow her flour sieve, put the sieve into the water as it was boiling, then throw the beetle in and just lift the sieve straight out. It's as quick as that. Pretty much instantaneous. And the specimen is relaxed and soft, so it hasn't been hardened at all. You can move the limbs around, do any mounting techniques that you want to use, and examine the specimen either under the lens or under the microscope.
The other way would be, you could put them in the freezer and then bring them out. And the thing that we were doing when I first learned how to do beetles, terrestrial and aquatic, we used to use a horrible thing called ethyl acetate, which isn't very nice at all. And that's a nerve agent that kills them. And then you can put them into settling jars, which we won't go into, which will keep them nice and pliable. But it's horrible, horrible chemicals, which are not very nice to use. So yeah, unfortunately, we do tend to drop quite a lot of them into 70% alcohol. It's not pleasant. But as Peter says, the boiling water thing's a very old technique, but you can tend to lose hairs off bodies if you do that as well.
For water beetles, As for many beetles, the boiling water technique is a good technique because it's instantaneous, but you wouldn't use it for things which are densely hairy because it can tend to mat the hairs so you can't see the body surface underneath them. That's the only problem. But if you then examine the specimens under liquid, then the hairs lift again. So it's a question of how do you then examine the specimen under the microscope?
I mean, it's inevitable that you can get a long way without even killing lots and lots of them, but it's inevitable when you're getting down to the real little tiny ones, like in the hydroporinites, I'm afraid it is quite inevitable that you're going to have to dispatch a few, especially males, and you can get males as well.
Yes, it's not easy to extract the EDAG from live specimens.
Well, no, we wouldn't want to do that, would you, obviously?
No.
Ethyl acetate is quite popular to use in the field, especially if you're going to be carding them at the end. And you have to remember with water beetles that if you're going to keep them alive and maybe put them in the freezer when you get home, you don't want to put too many in the same pot because they're predatory things.
Also,
absolutely.
Some of them are a little bit awkward to deal with in that way.
Yeah.
Yes.
Yeah.
Okay. So a question from a T. Davis is: are water beetles verified on iRecord? Now, I don't think Garth Foster is the national scheme organizer for water beetles, and I don't think he is verifying records on iRecord at the moment. But I don't know if his wife might possibly be in this Zoom meeting. If you are, Sue, then maybe you might be able to clarify that. Yeah, you could obviously send them directly to the national scheme as well on a spreadsheet. So it seems like Sue is here, or maybe it's even Garth. I don't know, but perhaps the nationals. You could recommend what your preference would be from a national scheme point of view. Well, I mean, I would say I use iRecord for everything now, and I know it's been increasingly popular from national schemes. There's an increasing verification goes on.
Can you see that?
Garth prefers direct contact with recorders, either with full details. So it sounds like the national scheme would prefer you to get in touch with Garth himself. So if you just go on Google on the Balfour Brown Club, then you'll find out how to do that. But yeah, as I say, I'm sure that the stuff on iRecord, because there will be thousands of water beetle records on there, that they will be used at some point. And it's just saying that Garth will sort of call in any suspect beetles and is more than happy to offer ID services. I know people do actually put the water beetles, obviously dead water beetles, in the post and send them to Garth, who offers freely sort of an ID service with that.
Very good.
Very good.
And Richard is saying that Bob Marsh verifies water beetles in Yorkshire. I don't know whether he does that.
Yorkshire Naturalist Union.
Yes.
So I don't know if Bob does that via iRecord or whether. I know there's local verification of iRecord as well, but that's normally agreed between National Scheme Organiser and the BRC. But I know there are some county level.
That's great. Brilliant.
And Sue's just saying that our post office is well used to us sending dry insects for scientific purposes. So sounds like you're not going to have any problems with that.
Excellent.
Yeah. Very good.
And sorry, I'm just reading out the chat really at the moment. And so Bob Marsh does verify them via iRecord.
Yes.
So therefore, if you're in Yorkshire, anybody, then
That's a good one.
your records are going to get verified on iRecord.
Hooray.
Yes, my record of macroplia has been verified on iRecord.
My record.
Our record.
I don't know if there's any other questions that I can't see any more questions in the chat. Have I missed anyone with their hand up there, Liana? Oh, I do have another question now from Giovanni. If you would sample the water beetles of a pond, would you consider sampling the nearby vegetation, and how far from the shore, with which technique? Also, how many times in a year to have a good representativeness? So I don't know, do you want to start with the sort of the first question there?
I'm happy to do that. The way I found Macroplia mutica was interesting over at Nosterfield. We were sat up right on the edge of a silt pond, and I was just looking at the edge vegetation, and that's where I found this beautiful beetle I hadn't seen before. Showed it to Peter, who obviously instantaneously knew who it was. And you could do a transect right out to see how far these insects go, and that would add to behavioural information as well, because we don't probably know how far from the edge of a pond that some of them go, or what they're doing when they're there. So any information like that is, you know, behavioural information rather than just location information. Is all interesting information for the national recording schemes, I would have thought. So my view about recording is get out every single month and do it. But get to know a local area, your local patch really well. Make it easier for yourself by getting to know a place you can easily get to all year round. And don't assume, like where we found Macroplia mutica, there'd been a major beetle survey. There'd been a big survey there of lots, not just beetles. And we were there just a few minutes, and we found another, that's when we found another beetle to add to the reserves list. Was it luck or was I looking? But go as much as you can to your local area, and do have a look at all the vegetation right the way up. But as for where would you stop, well, that's up to you. There's probably not an awful lot of information about that. So you can add to that.
You stop where you can't go.
Where, yeah, exactly.
Because if you're wearing Wellington boots, then you can wade about up to your knees.
But
if you're wearing waders, you can go deeper.
As for techniques, why not consider just sweep sampling the vegetation along a transect from the edge straight up to where you think it's dry? Because of course, in ephemeral ponds, so the water's coming and going all the time. You don't know, where does that water really stop? I mean, there's lots of extensive muddy margins you might want to look at. You might want to put a load of pitfall traps out along a transect and see what you get over a year or over a few months over the summer, whenever you think, you know, that you're able to reliably empty the pitfall traps, for instance. So you could come up with a whole range of stratified sampling that you could do over a year. So that would include things like a Malaise trap as well, maybe at the site.
But basically, the answer to the question is that you look wherever it's possible to find things, because there are always going to be things there.
This winter in particular, depending on where the pandemic goes, you know, it might be a very good opportunity to learn, you know, the water bodies and the water beetles in your local area this winter, because, you know, obviously we just had we've had our spring and summer, and we've been able to really get to know our local area this year. But you can carry on doing that with water beetles this winter if we do go back into more sort of restrictive lockdown. I can't see any other questions. Any final questions, anybody, before we wrap up this afternoon? Okay, well, there doesn't seem to be any, so I'll thank you all very much, and thank you to Peter and Sharon, and we'll be, as Sharon has said, there'll be a video in addition to the presentation going on YouTube, and Leanna will drop you an email when that is on YouTube, and you can watch it again, and hopefully you'll all be sort of inspired to go out and find some water beetles yourself and try and identify them.